So let's talk about the p-values here, and even looking up in a table. Since this is a stat class, if you're in version 8, it looks like, page 731. If you're in version 9, it's 705 that you need to look at. They give you an F table. And basically the idea there is look at your degrees of freedom for numerator and denominator for all your main effects and interactions. You got 1 degree of freedom. For the within group, it's 8. So you have to find the critical score. Degrees of freedom, numerator 1, denominator 8. It looks like for 0.05, the critical value is 5.32. And for 0.01, it's 12.25. So all these values, are they above that? Yeah, they're very much above that. You should only get positive numbers. So if you got this in a table, now we have to talk about writing out statistical and real-world conclusions. So let's actually start with writing out for the main effects of alcohol and pills. The way you would write that out is you write the letter F, and then right under it you could write in tiny little letters ALC for alcohol, and then open parentheses. And in the open parentheses, the degrees of freedom. Do you know what they are? 1, 8, close parentheses, equals, what's the F score? 800. And then you write what? P equals 0, 0, 0? No. P less than 0.001. Now the big issue here is what is the real world conclusion? For that, you actually have to go back to how you were looking at the visuals here. And if you were looking at the visuals when we went down the matrix, looked like when people got alcohol, it really diminished performance. So the real world statement is just a general statement that when people in general had alcohol, they were about 40 points below performance. So alcohol in general caused a decrement in performance by about 40 points. You don't look at the little cell means, you look at the marginal means to make that conclusion. Next, you would have to write out the F statement for the pills main effects. So you could write F and then write PILL if you want. And then open parentheses, same thing, 1, 8 equals 800. P, you wouldn't write 0, less than 001. Real world statement, when people took pills in general, their performance was decayed or was affected by about 40 points. Finally, for the interaction. So same type of idea again. We got an F ratio of 200 there because 1200 over 6 is 200. How would you write that out? F, you could write A times P. Times means an interaction. 1, 8 equals 200. P is still less than 0.001. And there you have to make a good real world statement. And what would that be? Just like the drug interaction, we have a statistical interaction here. When people took pills and alcohol together, it seemed to cause an interaction such that performance was really, really impacted in a negative way. It went down by what, like 60 points and not just 20 or 40. So when we do 2 by 2 ANOVAs, we can look for 3 specific effects, a main effect of A, main effect of B, and an interaction. I hope this made a fair amount of sense for you. You may have to listen to this more than once. I didn't want to do another example for you. I wanted you to actually try your own homework examples. So let me lay this out for you. It might take a little bit of work for you to try it, but give it your best shot. We'll go over it in class on week 10. So let's say you work for an insurance company. You want to see what your clients think about the Affordable Health Care Act. You give them a scale to fill out, 0 to 100. A high score indicates that they believe that government should play a very active role in subsidizing, that's helping out with healthcare, and a low number indicates that you believe government should only play a minor role in subsidizing healthcare. So what I gave you here is a data set, and I had a total of 12 people. I broke it down to Caucasians and non-Caucasians, and so one variable you can probably figure out is race. The other one is what kind of salary were these people making to begin with. So I have half the people were making a high salary, maybe say over 100,000. The other half were making a low salary. And so you've got some scores here on scales of 0 to 100. So see if you can use the information given and figure out what stuff looks like. Start out by getting the means for each of the little cells, then make your marginal means for race and for salary. Try to make a picture to see if there's an interaction. Now, you don't have to share with me the interaction, but try to do something so I can see what you're up to, and then see if you can fill out the ANOVA summary table and get the right answer here. Hopefully this will work for you. Good luck, and that will do it for today.